Afternoon, guys, everyone. My name is Matt Billington. I'm MD at Jigsaw Infrared, and what we're doing is we're working with infrared heating, and we're looking at doing a different approach rather than underfloor or radiators. We're actually producing, as per the image on here, a glass and aluminium infrared heating service and heating system. So as they're a little bit different, they're all made in the UK, and we're working towards 2025 when we know that the gas is going to be cut off from all the new builds. And we're seeing massive developments being made for decarbonisation in the UK and in Europe. So we're working quite hard now to find a system, provide a system that works really well with a good control, thermostat-based system, but also hot water, solar PV and battery. And we work with domestic and commercial businesses throughout the UK and the EU in providing a range of services. One of the most important things for us and to reduce our carbon footprint is we wanted to bring all these products back into the UK, and to be certified by Made in Britain was really important for us. So for that, we have our head office in the Midlands and some manufacturing here. We also have factories in Yorkshire, Liverpool and Glasgow, and they produce the glass infrared heating series for us. Even the aluminium is made in the UK. The heat mats are made in Essex for us. So it's really important that we support businesses, families, and also the Made in Britain badge. So infrared heating, the idea is we want to hide the heaters away, really. We can put these on the ceiling if you don't want to see them at all, really hide them that way. Or we can create mirrors and pictures like the one behind me, actually, and the one in the images. So you don't actually notice that these things are heating your room, apart from you might feel a little bit warmer around them. And one of the key points with the heating elements is we want them to warm up quickly, and this is where we see the big gap in the market for what we do. So the panels on the ceiling in the top left image literally take 5 minutes to warm up before you're feeling heat from them. So it's very quick response time. So we're kind of playing around with how we do this and how we make the home more efficient. So every building we work on is a complete bespoke design for the heating control system and the placement of the panels. It's not very often we do two exact buildings unless they're in an apartment block that we're working on. And the key thing with the infrared heating system is we don't need to have that room hot for you to feel the heat from it. So the holding temperature in our offices and in rooms it could be as low as 15, 16 degrees, and then we use a boost system just to warm that up. But as I said, as soon as the heating comes on, within 5 minutes, you are feeling the heat from that panel, even though the room might be still cold, air temperature wise. So the benefits of infrared, if it's completely safe, it's a natural product. We emit and receive infrared naturally. It's very energy efficient. It's 100% energy efficient. So the energy we put into the panels is the energy you feel through heat. But also the control system that we're using, it's about monitoring for every room. We're not just literally setting the heating on in a house to 20, 21 degrees and just walking away from that control system. We monitor every room within that space. And we've got a system that can automatically control what we do and how we do it. So infrared, some people might have heard of it, some people might not have heard it, but it's becoming more and more popular. And as with everything to do with building, we seem to be about 10 years behind mainland Europe. The Germans, the French, Austrians have been using this equipment for 10 plus years over us. So it's proactive system out there, and we're kind of just catching on. And in the last 5 years, we've seen quite an increase in companies that were, say, importing the equipment from China. We're seeing a couple of manufacturers making the stuff in the UK, and it's becoming more and more apparent. We're getting spec'd in council buildings, but also a lot of residential, but also larger developments, and home builders such as yourselves are starting to pay more attention to it. But the people get scared when we say infrared, because obviously it's the bad word obviously is radiation, but every light-based thing we see and feel is radiation, and so there's no hiding from that. And as I mentioned, we naturally evolved to emit and receive radiation and infrared. So when you're standing next to someone and they feel warm, that's the radiant heat that you're feeling from them. And the difference with this is what we're trying to do is heat the objects and the people within the space, and not the air first. And this is why you can feel warm in a room that's only set to 18 degrees and not set it to 21 degrees, which is a massive energy saving. And the key part from that, if we go back to GCSE physics for me and a little bit of A-level physics, it's all about the light and what it's doing. So obviously we've got the visible light in the middle, that's what humans can see. And then we've got all the nasties to the left, like the ultraviolet and the X-rays that obviously are part of natural light, and obviously UV can cause skin damage. But infrared is to the other side of the diagram, so it's completely safe. And with infrared, because it's a natural process, there are healing benefits to it as well. So as I said, we're designed to feel infrared and emit and receive it, but that has positive effects on our immune system. It helps recovery, but also it's been proven as well to possibly help people lose weight because it improves the circulation. And one of the key things that I definitely noticed the difference with suffering from hay fever and having family that have asthma is that when we stop moving air, when we stop circulating air within the space, it's actually a more pleasant space to be in as well. So infrared actually reduces the circulation quite heavily because we're not basing our system on heating the air and moving that around. There is still a little bit of circulation. It's not completely removed because we need the airflow to still be positively moved and cleaned, but it's a massive reduction. So it does actually feel very, very different from a normal radiator-based system or an underfloor system. And we're spending quite a lot of time actually doing R&D and research into the healing benefits of this, but also working with councils, working with the BRE to go through efficiency tests, producing models which can help improve our systems as well, especially the fabric of the actual heater itself, whether it be aluminium or glass. How can we refine that process? The control systems, yet again, are extremely important within that. So what sort of temperatures are really needed in a room to feel comfortable with infrared? So we're spending probably the next 18 months, 2 years doing some really in-depth testing with all these guys and with the BRE to provide a very much data and information driven response to what is going on with heating. And we all know that electric heating is seen as a little bit of I was going to say a swear word or a nasty point to do with heating at the moment, but we're seeing massive changes in the grid, even in the last 10 years, with renewable sources becoming more and more used and installed in properties. So we think we're quite positively are actively engaging with companies involved with solar, but also battery installation and renewable wind as well in properties. And with any new builds, with any retrofit as well, we are honestly bottom of the list of what people should be considering, and it's good to see that some of the other manufacturers and suppliers on this talk have also mentioned that it's not about just supplying our products. It's about making sure that the fabric of the building works properly first before we even get to the heating stage of it. Yet again, we're working with passive house builders, and really we probably only need one of our smallest panels in some of their rooms to provide enough heat within that space, because the building is doing the rest for them. And obviously that's the cleanest way to do it. That's the most renewable way to do it, and that's where we see massive reductions in energy usage and CO2 emissions. So if we're looking at that, if I was building my house now, I'd be looking at air tightness, obviously high levels of insulation, probably not pushing to passive standards, but getting really, really close to that, because that's what's really going to save money and save CO2 and energy usage. But as we see with COVID and people becoming more aware of pollution, obviously becoming a massive issue, especially in high rate areas and city areas, that air recovery and air swap out is really important too, especially with COVID and viruses that we're suddenly more aware of, definitely. But also, what can we do with the renewable energies we're putting on the building, within the building? And then last and not least, it's the heating and the hot water. How do we do this? How do we put this process into use so the building's working all together cleanly? And that obviously is making some big changes to what we're seeing with the SAP process, and obviously BRE and government legislation. So anyone that's ever sold a house or been through the process of buying and selling a house in the last 10 years or more now is really seeing this process of it becoming more important. I mean, 20, 30 years ago, we were talking about the massive invention of LED lights and how it's going to change the energy usage in the property. And we no longer leave lights on in a dining room just to make it look like we're home. We turn every light off, and we don't use those bulbs anymore, really. It's mostly LED processes, which means we've gone from a 100-watt bulb to a 5-watt bulb, which is massive reductions in energy usage. But when we're looking at obviously improvements to SAP and how that's going to change in the next year, is that mains gas has always been seen as the cleaner form of energy to use to heat your properties, when realistically now the grid is so much cleaner than that. So in the next version, which I'm hearing from BRE will be released next year, next June, we're going to see electricity become on a par with gas, which is good. Really, probably in the next few years, within 5 easily, we'll see far more electric production being made from solar, battery stored at home, but also wind turbines within the country. And we're seeing days like on Monday, and I think 80% of the energy produced on Monday was from green sources, and that's Bank Holiday Monday, which is the most we've ever seen in the history of the recorded process. And that's only going to extend and extend and extend. And we hear people talking about hydrogen as a possibility, as a future fuel source. But really, hydrogen is going to take six times more renewable energy providing sources to generate the hydrogen than actually just putting the renewable electricity into the property in the first place. So it might not be the best outcome. It might be a good way of tying in current boiler systems or current piping systems, but for new builds, it's not going to be the be all and end all. So I think this might be worth thinking of long term as well. And as I mentioned, so practically we are seeing massive increases in wind turbines. In the last 5 years, we've over doubled the production of them. We're only going to see more and more of that. Solar is increasing, and we're making massive jumps when it comes to reducing the actual household emissions, even in the last 27 years. And we've got big movements to kind of push forward to 2050 if we're going to get to net zero. And I think that's really ambitious with the current pace that we're leading towards. We're not doing enough at the moment. The government are not really supporting home builders really enough in the right directions. And we've seen from the delays in the SAP, SAP should have been released probably 5 years ago now for this update. So it takes too long for us to respond to this. And the positive feedback we get from people doing renovations, people doing the home building, is they are the driving force behind this net zero. And it's good to see that people really care about what they're putting in the homes and the homes that they live in, and the renewable sources that they will consider to make this work, even without the government's backing. And I think that's key for people to be able to make choices and decisions based on what they're doing. And sometimes the cost really isn't the be all and end all of these things. Building a passive house isn't cheap, but obviously the next 50 years of that property will potentially see that building be carbon positive. And that's what we need to do. That's what we need to get to. And how are we going to do that as a whole? And this is where the grid is really changing up. And this is the consideration we're seeing from our client base, is that people are thinking about what are they generating actually within their own property, and seeing their property as their process of generating their electricity. So we're seeing the decentralization of this happening already. So we're not reliant on the grid as much as we were for some places that are putting renewables onto their building. They're generating that electricity for themselves, whether that be solar, whether that be air source heat pump, whether that be battery storage that they generate from overnight systems or wind-based systems. And that's only going to increase, and we'll see people considering storing their own energy in their own property. So really they'll only take energy from the grid in off-peak periods, or when we've seen a surplus in wind and renewables, when we can charge those overnight. And that's where the tariffs are kind of moving to. We'll see a time of use tariff coming in where our heating system will respond to that cheaper drop down in electric prices, maybe from the 15, 14 pence per kilowatt down to 5 pence per kilowatt. And some of the big companies out there are already starting to do that. So we're starting to see British Gas, OVO, Octopus offering car charging over the night at 5 pence per kilowatt, which is a massive difference. I mean, it's 10 pence per kilowatt in just your bills to charge your car. So that means now you can top your car up for, say, £6 instead of filling it in diesel or petrol, which might cost you £50, £60. So that's only going to drive this further towards a greener future. And where we come in is we are looking for, say, the next 10 years of progression with our equipment. And we're seeing housing companies come to us now that are thinking 2025 and beyond. How do they start to implement these processes now? What do they do? What do they need to really make changes to see the benefits of this, and to test the processes now before we reach 2025 and they can't put the gas boilers in the system anymore? And one of the key issues, obviously, is getting enough renewables into that process. So we've got solar. We know solar is becoming more and more efficient, and the prices have probably halved in the last 10 years, where now a solar system and battery can cost, say, £10,000 or less. We've seen systems that are around about £7,500, and that kit would have been 15 grand even 5-10 years ago. So it's really becoming quite competitive to add this equipment to your building to make a positive stance now rather than later. And we're part of thinking about the greener, healthier environment at home. And as we see with the MVHR systems, we use yet again a decentralized system for our kit to clean and scrub the air and to extract the CO2 and the nitrous oxide from the building remotely, and operations automatically before it even gets to that point. And that, yet again, just provides a much cleaner space for us to live in. So how are we doing this? We've got tests at the moment with a couple of battery manufacturers that are looking to see if we can actually run our heating equipment from Tesla batteries or other options out there on the market. And the reason we're looking at Tesla is because they can output much more at peak time, so 7 kilowatts per peak, which is more than enough to run a good sized property. And obviously you can install more than one Tesla battery if you wanted to. And 5 kilowatts continuously is quite a lot of energy into one property. But we're also working in partnership with companies like Mixergy, which yet again can make use of the time of use tariffs. And I was actually paid last year by Octopus to put hot water into my cylinder because the grid was seeing a surplus. And yet again, we'll see more of that happening, where it'll become, say, economy 7 tariff, but throughout the day. So as I mentioned with the car charging tariffs between 12 and 4 a.m, we'll start to see the peak times happen around about tea time, when everyone puts on their evening meal or the telly for the first time. But during the day, we might have options to run washing machines or charge cars at much cheaper rates. And the equipment like ours, like Mixergy and Tesla, will be programmed to make use of that, so we can use the renewable sources but also keep our costs down, which really, with combinations to energy efficiency and home, should reduce our actual outgoings for gas and electric. So why are we using IR? And the biggest thing that I noticed when we started working with this is the speed at which we can actually get heat into the room. And our panels, like the one behind me, like the picture behind me, is surface mounted. So we're not heating a slab of material underneath the warm area before you get the heat feeling from it. So when that panel comes on behind me, as I mentioned, I can feel that heat within a few minutes. So it actually requires less heating, less energy than a convection system. It can work at much lower temperatures. So in the office, I don't know if you can see the actual thermostat behind me. I'm sitting in 18.9 degrees, apparently quite comfortably at the moment. Yes, I'm wearing a fleece, but why would I wear a t-shirt and stick the heating up? That's just a waste of energy. And when we consider these temperature rises, if I were to put that up to 21 degrees, 20 degrees, that would mean I'd need another 12 or 18% more energy to raise that to that temperature, which in essence is a waste of energy again. And in convection heat, we know that rad systems will lose temperatures in the piping throughout the process, and we have customers that come to us that have got other systems, and by the time it gets to the last room, there's not the energy in the heating system to keep that room to temperature. So with a decentralized system, we can actually program each room individually. And because we're not heating the air as much as another process, it's a far efficient source of energy transfer. We're not heating water to send that around a property. We're heating like the people in front of it, the people around the heater. So it's a direct energy transfer rather than putting it to something else, and then heating the air, which yet again is very inefficient. And the process of wall mounting a panel creates this even environment. 22 degrees would be tropical, in my opinion. 19, 20 would be more than enough. And I know the guys probably in the office would shout at me for that and whinge at me, but that's a massive energy saving. And we stop this hot-cold divide within the properties, within rooms as well, because we're not circulating the heat. We don't see the hot air rising because we're not heating the air, we're heating you. So it's much more direct. And our products, obviously, we're looking at a range of products. We're not just talking about one specific fit for everyone. So in the image top left, we have a panel system throughout that property, which heats downwards from the ceiling. So we kind of get underfloor heating sort of temperatures on the carpets still because it's directed. But we do mirrors and glass and the pictures like the one behind me as well. So they can be completely hidden. But then these are calculated depending on what space requires the levels of insulation. And the process of installing this kit is really easy. All we need is say a 13 amp feed maximum to these products, which is typical wiring 2.5 mil if you're looking into any electrical work. So it's dead easy to install them, and the brackets are designed that if you wanted to swap a glass panel around, you could take one off one panel and put another picture there, or if you wanted to move aluminium around the house, you can do. The system and the feedback we're getting from the clients is that we're seeing 50% saving over convection heaters and storage heaters, and that's kind of the minimum we reckon we can get to 60% shortly. So moving on, if we look at the product range, like I said, we're trying to keep it simple with the aluminium panels, and these can be wall and ceiling mounted. Any color we can do them in as well. So if you've got a special rail color, we can get those sprayed so they hide them. And we calculate these for exact requirements within that individual room. It's not a one size fits all. We calculate for every space, so it's easy to go through the process. Glass is a bit more sexy. Obviously, if you're looking for a bespoke finish, you don't want an aluminium panel on the ceiling. You'd much rather have a mirror. And these are kind of like the examples that we have within the office. But we can cut to any shape and size because we manufacture them in the UK. We can do pretty much anything you want with on the printed side of the images too. And they go up to a 1500 watt heater, which would considerably be more than enough energy to heat a 3x3 room, probably a 3x4 or slightly bigger, depending on the levels of insulation. The installation is dead easy. We've designed like an LCD TV bracket, laser level if you're lucky enough to own one, spirit level, put the brackets on and simply just drop the heater straight into it and wire it up. So we have an installation team that could probably do a 2-bedroom, 3-bedroom house in a day if it's already got the cable in there. A large house might be 2 days. So the actual response and installation is very quick. And coming on to quite an important part of what we do is the control system for that as well. So we want to make sure that we can, yet again, provide a good, nice, warm heating in that home, but also a controllable system. So this is what David mentioned very early on. This is the system that he uses too. So we're looking at controlling every room individually, but not just by app, but also by motion as well. So if you are not in that room, why are you heating that room to even above 18 degrees? It's a waste of energy. So we can control that system. So if you're not in the room, then we can have a fallback temperature to say 15 or 16, whatever preferred temperature you want. And then when you walk into that room, the heater will know that you are there for X amount of minutes, say 5 minutes if you're walking into the kitchen and making an evening meal. Then the heating system will click on and then respond very quickly. As mentioned, that could be as short as 5 minutes before you're feeling the heat from that panel. So it's a very quick reacting system and independent of each room. And we have seen feedback and case studies from even large hotel chains that say they save around about 60% on their previous system that they were using. So it's a massive difference in energy usage. And yet again, the reason we're called Jigsaw is because the puzzles within this piece are that you don't have to buy one type of thermostat. We can mix and match it. We can have a relay system, which is completely hidden from view. We can have a normal temperature-based system, which is touch control, or we can have that completely run off the motion sensor, which is also an air sensor. So we mix and match, and depending on whether it's like a HMO or a hotel or a domestic environment, we can literally supply a different system for each room if you really wanted to, but that's all controlled by the hub. And as I mentioned, the process is dead simple. If you don't want to see anything, if you don't want to touch any of the systems, which I think people are becoming more aware of, obviously with COVID, you will literally just walk into that space and that system will start to heat up depending on your preset settings. And one of the systems we did quite recently was a barn conversion in Exeter. And when the bats finally did leave the barn conversion, the couple were quite happily renovating this process and putting battery and solar storage on their barn next door. And what they found is that with plenty, I mean, 10 kilowatts is a lot of solar panels. They didn't have a bill, really an energy bill at all to run this property. It was well insulated and the mirrors were used and the panels used throughout the property. And what they find that even at 16 and 17 degrees, that's more than enough for them to feel pleasantly warm. And they just boost it as and when they need the process. So here we have the panels on the ceiling, on the eaves, and this will actually warm the bed and the fabric of the building, but also the carpets as well. So it's a nice clean system, but also one that means your bed's warm when you get into it on a cold winter's evening, which is fantastic. And we offer the full service. It's not just the heating as well. And we work from plans, from initial contacts, overview, and we do anything from large blocks of apartments, say 60, 70 apartments, down to single passive dwellings. So we've got quite a mix. We look at the heating, the controls, the mix of your hot water cylinder, which is a smart cylinder that can be controlled every 1% of the hot water within that as well. But also the PV and the battery and the installation, we've got options for too. And then COVID depending, we do a site survey where we can come around and go through the process on a room by room basis and look at the placement of all the equipment for best efficiency, and then obviously the style of preferred heater in that space. And as I said, the installation process might only be a couple of days. Usually a first fix, probably a day maximum for an average property. 2-day installation for a large property for a second fix. So it's really quite a straightforward process for us to get involved. And building this and working on this process, we get quite a nice response from our customer base. It's very positive, the views that they give us, and generally the heating quality that they feel. And some of the people like Danny on the right side, she said it was the first time the property has actually felt warm since she's lived in it, and she swapped out storage heaters for our kit, which is quite important to feel warm, to feel comfortable. But it's something that we can help with. And yet again, if there's any questions or anything you want to look into us any further with, or if you've got plans that you want us to start working with, we're happy to hear from you whenever you're free. Thank you.